Hello, geometry. Welcome to lesson 9.2 on proofs using coordinate geometry. What is very nice about this section is it does proofs, and again, we're going to do some algebra, right? Distance, midpoint, slope, but it generalizes these formulas. So instead of having specific numbers, we're able to use variable coordinates and really try to apply these ideas generally, right? And that's typically where true mathematics is proven, is if you can do it in a general case. Okay, but as you can see, we are going to do proofs. Okay. So number one, it says, how can you use coordinates to prove geometric relationships algebraically? Plan a proof for the trapezoid midsegment theorem. Okay, so notice it says plan, so we're not going to really execute this right here, right? It just says plan. And now, in order to do that, you have to know what the trapezoid midsegment theorem is. Okay. Well, the trapezoid midsegment theorem says the following, right? So, given, we're going to have trapezoid. We're going to call it A, B, C, D with midsegment EF. We need to prove that segment EF is parallel to both bases, and we'll make the top base AB, we'll make the bottom base CD. Oh, I'm sorry. We're gonna make the top base AD. I apologize. Don't let that mess you up. Sorry. So please erase this. We're gonna make the top base AD and the bottom base BC, right? And we need to prove that EF is equal to half, or equal to the average of the bases. So AD plus BC divided by 2, right? That's our goal. This is the trapezoid midsegment theorem, very similar to the triangle midsegment theorem, but because there was only one base, it's parallel to the third side, half the length of the third side. Here we have to include both. All right, so let's just draw a generic trapezoid like this. So if you can, use the origin as one of your points, right? And then we'll come up here, we'll go horizontal, and we'll come down here. Try not to make it look isosceles, right? Just try to make it look like a regular old trapezoid. And there's going to be our generic trapezoid we're going to use. So I'm going to let A be this point right here, and that's going to be the origin 0, 0. Now for B, I don't know anything about its coordinates, right? So I'm going to let B's coordinates be 2A, 2B. Now the reason I use 2's is because I know that midsegment means midpoints. I'm going to have to find midpoint here on AB and here on CD. So when I use the midpoint formula, I have to divide by 2. So it's nice to not have fractions, so to use 2's. All right, point C. I don't know how far to the right I'm going, so that's going to be a new variable due to C, right? But I do know that B and C are at the same height. They're going to have the same y value, so the y of C will be 2B. And then for D here, I don't know how far I'm going, so let's call that 2D, but I do know that its y coordinate is 0 because it's on the x-axis, right? And here's how I can generically label this trapezoid. So the first thing I would do, so step 1, is I would find E and F. And those 2 points would be midpoints, so I'd probably use the midpoint formula, right? And they'd be here and here, E here, F here, and there'd be that midsegment. Step 2, to show that they're parallel, I need to find the slopes of these 3 segments. So find slopes of segment EF, AD, and BC. And again, it's about being parallel, right? To show them parallel. And then the third thing, to show the EF is equal to AD plus BC divided by 2, is I have to find the lengths. Find the lengths of segment EF, AD, and BC. And again, that would be using the distance formula. again, which is just Pythagorean theorem. And this is the plan. Okay? All right, so now we're going to go through and execute that plan. I believe. Let's see. Nice. Okay, so here's the plan. Now, again, I told you different coordinates, so please edit this with me. So we're going to let B be 2A, 2B. Again, just trying to save you on the fractions. Let's let C be 2C, 2B. And then we're going to let D be 2D, 0. Okay? All right, so let's go through. So step 1, let's go ahead and find E and F. So we're going to use midpoint formula. So to find E, we have to take 2A plus 0 and divide by 2, 2B plus 0 and divide by 2. Just taking the x's and y's of A and B, adding them and dividing by 2. So that's going to be 2A over 2, which is just A, and that'll be 2B over 2, which is just B. So the coordinates of E are A, comma, B. I'll also find F. So we have to do, for F, I have to do 2C plus 2D over 2, and then 2B plus 0 over 2. Now, unfortunately, there's no way around it where we're going to have addition. But now, all those 2's cancel, and that's just C plus D for its x-coordinate. And then here, 2B over 2 is just B. Okay, so there's our midpoints, right? Okay, so now, for step 2, we're going to use the slope formula to find the slopes of EF, AD, and BC. Now, I'm going to show you one, but then we're going to talk about how they're horizontal. So let's find the slope of EF. Okay. So I'm going to take the coordinates of F's and subtract the coordinates of E. So y2 minus y1, so b minus b over x2, I'll put in parentheses, minus x1. B minus b is 0. The bottom doesn't simplify. It's just c plus d minus a, but who cares? If the top is 0, then the whole answer, if the top is 0 and the bottom is not 0, then the whole answer is 0. And again, these are horizontal lines. So the slope of AD will also be 0, and the slope of BC will also be 0. So if you smartly position your figure, you are going to be able to do some shortcuts. So yes, they are all parallel because their slopes are all equal. So we're going to say parallel. All right, so we proved the first thing, so that's proven, all right? So now the second thing we have to prove is that the lengths are the same, right? So we're going to use distance. Now again, I would not, well, for this one you kind of have to use the distance formula, so I'll do the first one, but then again I'll show you, because it's horizontal, what we can do. So to find EF, I'm going to take the F's coordinates and subtract E's coordinates. So we're going to take C plus D, subtract A, and that's going to be squared, plus B minus B squared, all under square roots, right? x2 minus x1 squared plus y2 minus y1 squared. Now here, this does not simplify, just C plus D minus A squared. C plus D minus A squared. But here, B minus B is 0, that goes away. So only you have the first thing under the square root, and it's being squared. So they'll actually cancel, and you get C plus D minus A. That's how far this is. C plus D minus A. Now, we can find the length of BC and AD similarly, just by counting, right? So because they're horizontal, we could have also counted that. We could have just taken the x of f and subtracted the x of e. That's how you find a distance horizontally. So to find the length of AD, I'm going to take the x of d, 2d, and I'm going to subtract 0, which is the x of a, and that's just 2d. And to find the length of BC, just have to take the x of c and subtract the x of b, which is 2c minus 2a. And now what I will do is I will use this formula. Right? I'm going to do it up here. So I'm going to verify that EF, which is C plus D minus A, is equal to AD, which is 2D, plus BC, which is 2C minus 2A, all divided by 2. Well, because these all have 2's and all the 2's cancel, and this is going to be D plus C minus A. And again, the C and D can be in any order. The minus A must be minus A, and that's true. So because we've shown that, this formula does hold. And we just use generic coordinates and the distance, midpoint, and slope formula to prove the trapezoid midsegment theorem with coordinates. If your mind is blown, that's okay. Again, in this section, the goal is to sort of get the idea, but just to use the slope and midpoint distance formula generically to prove things. All right, so that's video 1. Video 2 is coming up next.